Hi, today we are going to talk about the basic architecture of Libgdx, or rather the main classes and interfaces, and we're going to talk about the application lifecycle. So to start off, we are having a look at the application interface. The application interface is basically the main entry point of each Libgdx application. It provides you with a couple of modules for graphics, audio, input and files, as well as some convenience methods, or rather query methods, so that you can query the amount of memory used for the Java heap, the native heap, or the Android version, the application type, and so on and so forth. You can also get a preferences instance, which is something like a shared preferences instance on Android, which allows you to store any persistent state which is small, like, I don't know, whether sound and music are enabled in your game, or how high the volume is of your music. And you can also post a runnable. So what would that mean? Well, Libgdx has a couple of backends, and each backend operates in the same way. When you start an application on a desktop or on Android, you usually have something called the user interface thread. This is something each application on each platform will instantiate automatically. On the user interface thread, you usually handle things like redrawing your UI or processing touch events and so on and so forth. Now, this has nothing to do with Libgdx really. We abstract it away from you, and you don't ever interact with the user interface thread. So instead, what we do is we create a second thread in your application, which is called the main loop thread. That main loop thread is responsible for updating your application or your game and rendering to the screen, processing user input, and so on and so forth. So what's a main loop? Back in the old days... No, go away, go away. Nate is always bugging me. Yes, this is going on YouTube. Awesome. Okay, so what's the main loop thread? I think I'm just going to disable Google Talk. Oh, this is awesome. This will so piss him off. Great. So, back on topic. In the old days, you usually did something like load all the assets of your game, or partially load them if they don't fit into memory. And while the game is not finished yet, repeat something like this. Process the user input, update your game world, and finally render your game world. So that's the main loop thread. The asset loading was actually done outside the main loop. So it's not the main loop thread, it's the main loop. On modern operating systems, this can be done, but usually you don't. So what we did in Libgdx is adopt the event-based nature that you usually have when you interact with the user interface thread. So for this, you have to register a so-called ApplicationListener with your application. We already did this in the last video, and we are going to talk about it in code a little bit more in a minute. So that's the ApplicationListener interface, and that's your main entry point. You basically implement all these methods here, which are 6 in total. Register your application listener with the application instance you have, say a Joggle application on a desktop and an Android application on Android. And the application implementation will then take care of calling these methods on the main loop thread when appropriate. So when is which method called? The first method which is called is the create method. It's only called once and only on application startup. Next, the render method will be called as often as possible by the application in the main loop thread. Within this render method, you basically perform all the stuff you do within your main loop, usually. So why don't we have a separate update thread and a render thread? Well, it turns out that that's actually not all that beneficial, even though it's advertised heavily on the web. It might come in handy if you really have computationally intensive updates, but even then you can do a little trick. You first render, then update within the same thread, and then call the swap buffers method, which is done automatically by GL Surface View on Android or Libgdx itself. What will happen is that while you update your logic, the rendering commands you issued before that will get processed by the GPU in parallel to your actual update code. So this way you can actually get away with not having a second thread. Okay, so back to the application listener. So first create will be called, then render as often as possible. On Android we have the problem that our application can be paused. So for this we have pause and resume methods, which will be called appropriately. So when the user presses the home button while the application is running, the application will be put in a paused state, and the render thread or the main loop thread will be put to sleep. Once the user decides to go back to the application, the resume method will be called. So when can a pause invocation happen? This happens if the user presses the home button, or if there's an incoming call or any other event that takes away the focus of the application. Resume will happen if the user goes back to your application by, say, pressing the home button for a long time and then selecting your application again. Finally, when the application is quit, the dispose method will be called. It is preceded by a call to the pause method, as we are going to see in a bit. The last method in the application listener is called the resize method. This method is called when the window is resized on a desktop or when the orientation changes. Basically it's called anytime the rendering surface we are rendering to changes its dimensions. So let's have a look how this works in code. For this I have two projects, which I basically set up the same way as in the last video. We have the main project, which contains the main logic in terms of an application listener implementation, and a starter class, which is just the public static void main you usually used to on the desktop. So here we instantiate a juggle application, which will, as I said, create a thread. And we set a lifecycle test instance, which is the application listener we are implementing, as the application listener which will be invoked appropriately. On Android we have exactly the same thing. Instead of a juggle application we are using an Android application, and we also put a new lifecycle test instance, or registered this instance with the Android application. So let's see what our lifecycle test is actually doing. We basically just implement all the methods of the application listener interface and put logging in there. So we have a log tag like in logcat and the message itself. We also have a member which is a random instance, so we can get random numbers. We'll use this to clear the screen. And each of the methods will output what's happening. So when resume is called, resume will be output to the console or logcat. When resize is called, resize event is output along with the width and height of the rendering surface that changed. And that's true for the rest of the methods as well. The only exception is the render method, where we set the clear color using the random instance. So these are the red, green, blue and alpha components of the color we want to clear the screen with, which are in the range null to 1. And we also clear the screen, of course. This is just basic OpenGL. We'll get to that eventually in the next video. So let's run this application on the desktop and see what happens. So, as you can see, the create method is called once, and the resize method is also called once with the dimensions of the rendering surface. The render method clears the screen with a random color each time, so you get a seizure, which is great. And there's no pause events on a desktop, so you'll only get the create and resize method while the application is running. When we close the application on a desktop, the pause method will be called, as well as the dispose method, in that exact order. An interesting fact about all those application listener methods is that they are actually all invoked on the main loop thread, so you can do OpenGL stuff within those, no matter what. Okay, so let's run this on Android. I'd love to use the emulator for this, so you can see it in action on screen. The problem is my netbook is not good enough to run the emulator. It will not boot up, even if you let it try for like 20 minutes. So what I've done instead is hooking up my lovely HTC Desire HD, and as you can see I already ran a test beforehand, so let's clear this. And I'm going to start the application on this device. we'll only see what we are logging to the logcat here. So I'm sorry that you don't see the screen, but it's basically the same as we saw in the desktop application. So let's run this on Android. Okay, so the application is started up and the create and resize method are called. So what I'm going to do next is pause the application, and this is done by pressing the home button, for example. So that's to be expected. The pause method was called. Next up, I'm resuming the application by long pressing the home button and selecting the application again. And that's that. So here something funny happens. The resize method is called twice. This is a problem which stems from the GL surface view which we are using. All we basically do is report what the surface holder, I guess it's called, no, surface something something, is telling us, so there's no real workaround for that. Usually it's not a big deal that the resize method is called multiple times after resume. So what happens when we exit the application with the back button? The pause and dispose method will be called. And that's really all there is to it. So to summarize, on startup we have a create and a resize invocation. While our application is running, the render method will be called as often as possible. If the user pauses the application on Android, the pause method will be called. If he resumes it, the resume method will be called along with one or more resize events. And if we close the application, the pause and dispose method will be called. So that's basically it. Okay, ciao.